bit. And okay, here we go. So this is the update for the fourth day of the Ant CNC PCB mill build. And today was all about motors and motion systems assembly, which is probably my favorite part. It's kind of a shame that it was so short, because I found this stuff to be very interesting personally. So the first step was probably the most annoying one, which was to insert the chuck, so the tool holder here in through the head and into this pulley on top, which gets wrapped to the actual tool motor, the brushless motor. Um, Doing this on the end team's video was painless and like very simple. All they did is just get it through there, fit perfectly, and then they used a lock collar on top to sort of make sure that the tool holder doesn't fall down or the chuck doesn't fall down once it's inserted. On my end, it was not nearly as simple because after measuring the inside of the Mochu 706C bearings, I saw that the hole was at 5.96 millimeters, which is very close to 6, but not 6. Whereas the rod itself was, I think it was very close to 6. It was like 6 millimeters, 6.01 millimeters. Thing is that like 0.05 millimeter difference for metals is very significant. And so it was extremely hard to actually insert the tool holder inside the bearings. So much so that when I just inserted a tiny bit, saw that obviously this wasn't going to go through all the way because it was way too snug. When I pulled it out, I actually pulled out the entire bearing with it, and so everything was sort of all the ball bearings were spread everywhere. The outer ring, the ball races, and then the inner ring were just separate pieces at that point. And the way that bearing is made is not like other bearings. Actually, a lot harder to put back together, even if there is less pieces. But what I did is I used a little tool, something I printed from Thingiverse made by Presley 4B. I'll have the link in the description for anyone who wants that tool. Essentially, it's all sort of a small round table. I'll get it. Um, all right, it's this little thing here. So you have this pusher. You have this little like work table if you want. You start by putting the outer ring and putting the pusher inside, but not really far. And then you put the races inside. You place the ball bearings all around. There's 8 of them, and then you make sure that the space in the middle is free of any balls, like nothing is touching. You place the inner ring, and then you just push up, keeping your fingers on top, and everything should snap back in place. And it does, oops, it does work like wonderfully. So I'll definitely have that in the description for anyone who has a similar problem. To try and get the tool holder to actually fit, I use some sandpaper and my drill to actually remove some material with the metal this is made of. This was a pretty long process, but at the end of the day, it actually ended up working pretty nicely. And I was able to fit the tool holder through both bearings. Although when it got to the very end, it got very snug, to the point where I am almost convinced that it is impossible for me to remove the tool holder from this now that it's in there, or remove the bearings or the inner rings of the bearings from the tool holder's shaft now that it's put in there this way. This is actually something very similar to this pulley here on top for the tool. In the end team's video, they actually do have to apply some force to get it in there. and then the lock collar exists to just make sure that everything stays at the same height. I didn't have. I actually had to push it in very hard. The point I actually hammered it. I had to hammer the tool holder inside of that pulley, and I am actually pretty satisfied of the final result because what happens is I have a tiny bit of space between the pulley and the first bearing on top, and then a tiny bit of space still between the tool holders, sort of the chuck itself, and the bearing at the bottom of the head. So I'm not like I'm not I don't have any friction with either the bearing races or any other part of the bearing for that matter, which is very good. This ideally is what you want to have is just the smallest bit of space there so that you actually do not contact directly the other parts of the bearing. So that took a while. I'd say that took like probably 2 to 3 hours to try and figure all of this out. And I mean, again, like removing material from the tool shaft was a very lengthy process, but everything ended up working in the end, and it was good for that. Uh, the last thing I did actually before mounting everything else was to heat the use the little heat gun trick on the linear bearings again to make sure that everything was nice and smooth. I did it quite significantly on the head because that was sort of snagging up, as can be seen in I think the first update video, which is the second video on this subject after the live stream. I mean that video was right after the last stream, but it all in all is a second video. Anyways, so it snagged up a bit, but now with the added weight and that process of heating the outside of the head part again, everything now fits very nicely. It's very smooth, and the movement is quite nice. I didn't do it for the y-axis because I personally think that it's more than fine. But if it becomes a problem in the future, I will know that I didn't do it on the final step like one final time, and so maybe that could be done to try and make everything a bit smoother. Um, so the next step after inserting the tool holder was to assemble the motor, the brushless motor. That was very easy. I don't know why they have four holes. I know that usually brushless motors have four threaded holes. I don't know if you can see, yeah, that angle here. There's four holes here, so usually brushless motors will have four threaded holes. Two like they're separated in opposite pairs, and two of them will have a set distance between each other, and the two others will usually not have the same distance. But for this specific brushless motor, which is quite funny because in the N Team's fourth video, they use this exact turning E Hobby King motor, but in the cable prep, they use the mystery AliExpress motor, which isn't in stock anymore. So I don't know what's up with that, but hey, at the end of the day, I use exactly the same motor as they do. The Turnigi 2632 1000 kV. So there you go. And that motor actually has all the distance, all the threaded holes on it are equidistant. So there's really no reason to have the four holes there unless they're sort of assuming that other people may use other types of motor. Something that might be reflected in the pulley part. So they have one part which is essentially three. They have one STL file which contains three pulley parts. The pulley for the tool holder, and then two pulleys for the motor. One which has a very small hole for the shaft, or at least very small compared to this one. And this one has a significantly larger hole. I think this one is like a 3.1 millimeters at the base. So without any kind of tolerances coming out of the printer, whatever. And the other one is like 2 millimeters instead. So there's quite a significant difference. In the beginning, I was trying to fit the 2 millimeter one on the shaft, and this motor has a 3 millimeter shaft, so obviously that wouldn't work. I tried drilling it, and I realized, wait, there's another part with the proper hole size. Let's just use that instead, and then it worked pretty fine. I don't know how problematic the height. What? Let me show this side actually. I know how critical the height of this pulley's sort of indents versus the height of this pulley's indents is going to be when using the O-rings to as belts. But this pulley is not moving. There's no way. With the chuck I have and everything, this pulley cannot move whatsoever. But this one can move slightly with some significant amount of force applied, but not enough to break any parts. So I guess I can adjust that if it becomes very important, which I think it might, but maybe not. Then it was just screwing in these the stepper motors, the two NEMA 11s. I think mine are a bit shorter than the ones used in the end team's video, but it should be fine. They're about the same size, really. And lastly, like this, I didn't take care of which one I connected where. So there's one where the arrow corresponds to a blue wire, and one where the arrow corresponds to a green wire. I didn't really take care because I really couldn't see it from the end team perspective, the end team's videos perspective. But since these cables I cut long enough so that they can reach both sides pretty nicely, I can essentially interchange them whenever the connections are going to happen. Although I think I think that putting the wires at the correct place is probably more important than having the correct order of coils. And after all, that can be changed by simply changing where the crimps are inside of the plastic connector. Adding all these motors onto this kind of add like a significant amount of weight. So now this actually has heft. It's no longer super light, but it's not really heavy either. I think most 3D printers are going to be heavier than this, but I mean this is very small. So for a machine this size, I think it is a bit heavy, but again, it's really not that bad. Next is the Z motor. So I said I think in the previous video that my Z motor is the same in every way, shape, and form as the one used in the End Team's video and in their base project, except for one thing. The physical package is slightly different. So the rod inside of the motor, its output, instead of being a externally threaded M5 thread, is actually internally threaded M3. So that's a very slight difference. And honestly, it doesn't really matter. It just means that instead of having a M5 nut here, I have a M3 bolt with a washer. Now, the way it's made is a bit weird because, well, it's not weird. It makes sense, but it makes everything a bit weird compared to the original plan because right now there is like some slack here because obviously I'm threading inside of that plastic rod and it's smooth on a bit of length besides just the tip, and there's no like retaining nut or something you can thread on there to give it a bit more support. So what I'm probably going to do is just try to make a ring that sort of accounts for all of that and make it nice. Although I don't really think it's all that important that this be snug, completely snug, because this motor essentially allows this head to gently come down or just pull it up. Although now that I think about it, you may need some force in there to sort of penetrate through the material. So the having this little ring here may be fairly important after all. I tried using the 3D printed part that I showcased in the last video, I think, on there to give it the same physical package as the original version, but the M5 thread on that is just not good. The head ended up dropping every single time I tried screwing the M5 nut, so I didn't feel like that was a viable option. So I didn't do it. I didn't end up doing it. Um, yeah, so that's one thing that may be left. And now the fun part, the belts. So wiring, all this belt routing, which is extremely well conceived, by the way. This is probably one of the things that made me want to do this project the most is the belt routing around this that is very ingenious, very nice. I understand that it's the basic core XY stuff, but seeing it implemented like this is still very, very fun. Even if it does use these GT2 16 teeth pulleys that are that have a 1 centimeter wide length of teeth. That is a rare part. For some reason, I had like this random shop, 3D print in Canada that had these pulleys in stock. I don't think are they called pulleys? I'll call them pulleys. They had these in stock. It's probably a thing that is more common to see in exactly Core XY builds because they're really rare to find anywhere else. So take it as you will. But at the end of the day, it really didn't matter all that much. With everything routed, with all the modifications I did, shown during I think video two, everything was smooth. Everything rolled nicely, and still rolls nicely. Actually, a nice demo is to try and move the motors and exactly see how the Core XY stuff works. So if you rotate one pulley here, it really moves 45 degrees, right? And if you rotate the other, it moves 45 degrees in the other direction. And only when you combine both of these movements can you get true X and Y motion. So that's pretty interesting. Right now, the belts are only manually tensioned, meaning that the tensioning part here, that by the way is probably one of the best designed parts on this. It's very clever, fits in very nicely. Essentially, no problems with this, especially the belts. I thought that there were going to be considerable tolerance considerations to be had here with maybe the ring not being large enough or the belt not being too wide, not fitting in because of the 3D printer stuff, but really just with a bit of force, the belt just slots right in and there's no issues whatsoever. So that's very, very nice. And also the inbuilt tensioning method of just taking one of these M3 by 25 bolts and just screwing them in, tensioning the belts. And right now they're just moving very nicely, just with basic tension. These are at their maximum. They can be tensioned quite a bit more than this. So yeah, I think everything's gonna be fine on that end. One thing I did want to say about the belts is I found out that the way the belts are sort of attached on the sides here means that you don't really get to go all that close to this piece where the end switch. Let's see if I can show this. Yeah, the end switch here. I don't know if you can see it. Yeah, this guy here sort of contacts the bolt here. So I actually had to screw this guy outwards up until when you move the head all the way towards that side that you hear a click before anything sort of touches the that is either the remaining bit of the belt or the tie wraps touches any other surface. So that limits the movement slightly, but I honestly don't think it's gonna be that huge of a problem, considering that you already have like a pretty wide range of motion around this guy, and PCBs don't tend to be so huge. Especially, I wouldn't recommend trying to make such huge PCBs with this machine. This is still like probably some kind of this is still like some hobby grade machine, and so like doing very large PCBs with this is probably not advisable. So yeah. One last thing I do want to say is after all of this, um, I still have these rods poking out. So these all are 100 millimeters exactly, which the end team says that this is what you should get. And if you have exactly 100 millimeter long rods, you will not have any problems. I did not have to cut any of these two rods here. They came in at 100 millimeters, but I had to cut these threaded rods, and I'm a bit annoyed because I would have. It's not really so bad. There's a couple other people that have this issue, obviously, um, and all they say is, "Oh yeah, make them poke out the top and it's fine." And at the end of the day, it's really not all that bad. I may have I actually talked about this earlier, but it really doesn't add much more weight. It's just a bit less satisfying. And since like I said, I cut these threaded rods manually, I would have liked to know the right size. I had to cut these long rods to exactly 18 and it didn't end up being flush. Then these, obviously I didn't have to cut, but if the end team was like, okay, you need exactly this size of rod for this application, I would have just cut them also to size, to proper size, instead of saying, oh yeah, 100 millimeters is fine, and no, it's not. It's not flush. Even though it's not a big of a problem, it's a bit of a peeve. And yeah. Anyways, so I think that's essentially it for now. It's a very short day. Um, I'm not sure what's next. I think it's the electronics. So just electronics assembly. That may take a while, depending on how good I am at soldering stuff, I guess. Tomorrow it was really annoying to do the 16 gauge cables because there's so many goddamn low wires in there that the solder doesn't really like it. Especially I was using unleaded solder because that's what I have the most of right now. I've used leaded and unleaded. Unleaded is much worse than leaded solder. It doesn't stick to anything, even with the rosin core. And I mean, when I solder, I always wear a mask, which a P100 mask to make sure that all those nasty fumes don't get in my lungs. And honestly, like if anyone is bothered by lead being present in leaded solder, obviously the one I have is 6040. The rosin core, which is also present in the unleaded solder, is also significantly dangerous. I think the fumes from that are actually quite toxic as well. So no matter what, you should wear some kind of protection, even if you just have a fume extractor with some kind of activated carbon filter. Sorry, that's probably good enough. I use a mask because I don't have one of those fume extractors. I think they're too expensive, and the mask, I got it for free. So at my previous job. So there you go. And yeah, so that's it for